And we are live. Here we go. Geometry, chapter 6-5. We're talking about rhombi and squares. That's right. The plural of a rhombus is a rhombi. A rhombus is a parallelogram with all four sides congruent. So you can think of it as a rhombus is to a parallelogram as a square is to a rectangle. The diagonals of a rhombus intersect at a right angle. They are perpendicular to each other. That is Theorem 6.15. Theorem 6.16 says that the diagonals bisect a pair of opposite angles. So 1 and 2 are equal, as are 3 and 4. So these are congruent to each other. So here we have an example. We want to find an angle. Now there's multiple ways to do this. We want to find if FGH, if this angle down here is 82, this angle right here is 82, we want to find KHJ. So we want to find this angle. So there's multiple ways. You can figure out this triangle right here. You've got 82 degrees here. And since this is a rhombus, it says it's a rhombus. So then we know that these bisect each other, so we know that these two angles are the same. So we could find it this way. Or we could say, because it's a rhombus, the diagonal bisects it, so this angle right here is 41. Now we also know in a rhombus that this measure is 90, because the diagonals are perpendicular to each other. And then calculate right here from 180, and that gives us 49. All right, we know the diagonals intersect at K, so if GH is x plus 9 and JH is 5x minus 2, we want to find x. So label those sides. Now we know in a rhombus, all the sides are congruent to each other. Okay, so that means we can set these two equal to each other and then solve for x. So x is 2.75. A square is a parallelogram with 4 congruent sides and 4 right angles. So if you look at all the parallelograms, we've talked about rectangles. That's a parallelogram with 4 right angles. Now we talked about rhombi. That's a parallelogram where all the sides are congruent. And a square is both a rectangle and a rhombus. So, conditions for them. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus for sure. If notice only one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. Because if one of them bisects, the other one will automatically do so in a parallelogram. If one pair of consecutive sides, so sides next to each other, are congruent, the parallel is a rhombus. Because remember, in a parallelogram, the opposite sides are congruent already. So we write a 2-column proof. We know that this is a parallelogram, and we know that JKL is isosceles. We need to prove that JKLM is a rhombus. So we know it's a parallelogram, that is given. We know it's isosceles, that is given. We know that KL is equal to JK because we know this is an isosceles triangle. That's the definition of an isosceles triangle, that these two would be congruent. Therefore, we know that JKLM is a rhombus because consecutive sides of a parallelogram are congruent. And that's all we have for today, ladies and gentlemen. Like and subscribe, and I will see you next time.